Morning, everyone. You're gonna have to forgive me my voice. I'm trying to fight a cold, but hopefully we can push on. If you can't hear me, okay, or if I say something and you're like, what was that?" Just stop me and let me know. Hopefully Elaine can translate my scratchiness. Anyway, today is day 25 of Math 133, and we're going to cover the Chapter 10 review. Uh, Today we are 3 weeks from the final exam. Um, so the reason I'm pointing that out is because um, normally I'll accept late work. Like if you turn something in a couple days late, you lose a couple points. But if you turn something that's more than 3 weeks late, I won't grade it. Okay. So that was true up until this point. Um, Everything going forward has a solid deadline um, that's a little shorter than 3 weeks. So today is November 20th. I need to have all assignments turned in by December 12th. December 12th is Friday after the final exam because I need time to get those graded because I have to have all of my grades turned in by that following Monday. So if you know, uh, next week, if you get an assignment and you're like, oh, I don't have time to work on it, I'll wait a couple weeks. You can't wait a full 3 weeks from there. So because December 12th, midnight, everything needs to be turned in by December 12th at midnight. Anything turned in after that, I'm not going to be able to include it in your final grade.
That's still putting a lot of pressure on you.
Sure. Yeah. No. So I do appreciate you guys turning things in on time. I know that I'm a little slow when it comes to grading, and I apologize for that. But I'm going to use Thanksgiving break and try to crush through like as all the backlog of stuff. Um, anyway, yeah. So this class is a lot of work, as you guys have seen. It's a lot of work on your side. There's a lot of things to turn in, which translates to a lot of work for grading for me. But it's okay. It's good. Okay. So let me uh, pause my microphone so I can cough. Okay. So today we're working on the Chapter 10 review, which is on page 526. 526. All right, page 526. And I'll look through here. We'll give you some hints and then we'll go back through the assignment. Um, all of this information uh, is going to be today on pages 262, proportions, and then page 263 for means. Okay. So, uh, pretty much everything we're going to cover today is covered in those on those 2 pages. Okay. So, let's see. Okay. Um, I'm going to start here. Pairs of p-values and significant levels are given for each determine whether the observed p-value leads to rejection of the null hypothesis. Okay. So step 5 says if the p-value is less than alpha, we reject the null hypothesis. Okay. So that's all we're doing. We are checking to see if the p-value is very small, we reject. Okay. So for A, reject or no. What do you guys think? If the p-value is small, we reject. Smaller than alpha, that is. So yes or no. The good news, today is not test day. So if you get it wrong, then no big deal. Yes. Thank you, Andrew. 0.02 is smaller than 0.05, so we reject. Good. How about for answer B? So they're equal here. And we said that if the p-value is less than alpha, we reject. This is not a less than or equal, so we are going to not reject it. Now, I'll pause here and point out we've played really fast and loose with less than or equal in this class. And that's because the chances of this happening are almost zero. The chances of having exactly equal alpha and p value uh, is it's never going to happen. Okay, so okay, let's say that it does happen. Well, most of the time when you're doing these tests, you're hoping that you get to reject the null hypothesis. You're so close, right? If this was 0.00399, we'd be like, oh, it's less, and we reject it. So, um, is rejecting the null hypothesis here a good idea? It's probably not, because you could make an error, right? We'll talk about the type errors, type 1 and type 2 errors. But if it's this close, it's going to be reasonable if you do end up rejecting it or not. Okay. If it's equal. Okay. Now, technically, it is a no. The answer here is no. But like I said, if they were exactly equal, I probably would opt to reject. Anyway, I'm going to let you guys fill in the other ones there. So, which study has the lowest chance of a type 1 error? The chance of getting a type 1 error is alpha. Okay. So, which of these alphas is smallest? A, B, C, or D? Answer B. Correct. Mm-hmm. Oh, sorry. B, because has the smallest alpha. Okay, next. Which study has the lowest chance of a type 2 error? Now, a type 2 error, the chance of getting a type 2 error is called beta, and we do not have beta here. Okay, so technically we cannot answer this. But let's say that these studies all have the same sample size. If they all have the same sample size, then you can answer it based on alpha. Okay, beta is based on your alpha, but it's also based on your sample size. Okay, it's based on a couple other things, but um, in this case, which of these alphas is the biggest? Answer A, largest alpha. Okay. Which studies had statistically significant results So that's going to be the ones that you circled for yes. Okay. Um, oh, sorry. Which study is the most statistically significant? That's going to be whichever one has the smallest p-value. Okay. Small p-value means it's very unlikely. It's statistically significant, meaning uh, this isn't just from random chance. We're taking a random sample. So anytime you take a random sample, there's always some chance that you end up picking something weird. Like it is possible to flip a coin and get heads 100 times. It's very unlikely, but it's possible. Okay. However, it's so unlikely that if that happens, you can probably guess that something weird's happening. Maybe it's a double sided coin or something, double headed coin. Okay. The same thing is going to happen when your p value is so small that you can reject the null hypothesis. That means that you can be confident that this result wasn't just some random chance. Okay. We know that it could be. It is a random sample. It is possible that your entire bag of M&Ms is all blue just because it's random. Okay. But it's so unlikely that if it happens, you can guess that something weird is happening and it's not because of random chance. So, anyway, so whichever study is the smallest p value, that's your answer there. Okay. Lastly, for question F, we do not know if any of these studies had results that were practically significant. Practically significant means it actually matters in real life. Um, so when we were counting blue M&Ms and we saw that like, oh man, there's a lot of blue M&Ms. Does that matter? It doesn't make practical significance. Not really. Because who cares? Who cares if I get too many blue M&Ms in my bag? They all taste the same. so um so it doesn't matter. Okay. But on the other hand, if we were testing some new medicine, that data would matter. It would save lives or possibly endanger people's lives if we make an error and we put out a medicine that's not effective. Okay. So for this case, for question two, we've got all these different studies we've done. Why don't we know if any of them were practically significant? Well, we have no context. We don't know what the heck we're measuring. We have no context. A lot of times in this class, we do story problems. We do a lot of story problems. And that's partly because I want you to be able to understand why this stuff matters in real life, but also because it makes it easier to tell if this stuff matters or not. They didn't tell us what we're measuring, so I don't know if it matters or if it's important or not. So anyway, all right. In June 2020, early days of the pandemic, Johns Hopkins researchers released a study that in the US, there was a 38% false negative rate for COVID tests. What does it mean for the COVID test to give a false negative? A false negative means that the test says it's negative, negative meaning you do not have COVID. Okay. So the test says you do not have COVID, but it's false, which means that, oh, you actually do. So what does it mean? It means a person with COVID tests negative, but they are actually sick. actually have COVID. Okay. Person with COVID tests negative, but actually they have it. Okay. Why is a false negative result a problem? What do you think? Well, yeah, it's an error. Okay. But there's two types of errors. One is false positive, one is false negative. A false positive would be the test says you have COVID. Positive, it tests positive, but it's false. You're actually fine. That's an error, but it's not as big a deal because if the test says you're positive, you're going to be like, oh man, that means I have to quarantine, I have to stay home, but you're actually fine. That's not a huge deal. I mean, maybe you'll miss a couple days of work, or maybe you'll have to have someone, uh, you know, someone else will have to, go to this grocery store and bring you groceries. But like, if you if you think you're sick but you're actually fine, that's actually it is an error. It's not an accurate reading, but that's not as bad as a false negative in this case. So a false negative is worse here because um a false negative, the test says you're fine, but you have COVID. What are you going to do if your test says you're fine? Well, you tested because maybe you were going to go to a concert or you were going to go out, with friends, and you're testing your to see, oh, can I go? Is it okay? Am I sick? And it says, no, you're fine, but you actually have the disease. This person is going to spread. This person will spread the disease to others. Okay. That's much worse than someone who's has to stay home when they didn't actually need to. Okay. Does that make sense? Spreading the disease to others, that puts other people at risk. You know, that's not good. When we're looking at these errors, both types of errors, type 1 and type 2, are errors, and both of them are not accurate readings. But sometimes one of them is worse than the other. Okay. And so in this case, we probably should have made our alpha much smaller. Okay. Because the probability, or sorry, the problem of a type 1 is much worse than a type 2. Now, that's not always the case. Sometimes a type 2 is much worse. Uh, and we'll see that as we go through this exercise. Sometimes they both suck. I mean, uh, if if you want to go out with friends, you bought these concert tickets, you test yourself and it says you're positive, and now you have to stay home, but you're actually fine. I mean, that still sucks. Okay. But it's not as bad as getting other people sick, spreading the disease. Okay. All right. I did not test myself for COVID, so hopefully that's not what I have. Anyway, manufacturers designing a new jet part that is critical for keeping the engine going and the plane in the air. Manufacturer is testing the part for strength compared to the older traditional part. If the new part is stronger than the old one, the manufacturer will install it in their new jet engines. Okay. So we're going to fill in our null hypothesis. New part is not stronger. So our alternative hypothesis is just going to be the opposite of that. The new part is stronger. Okay. Now, uh, the actual situation is going to be the exact same thing as what we wrote here. Okay. New part is not stronger, or the new part is stronger. Okay. Now, we don't actually know the actual situation. Okay. Because I can't test the entire population. I can't go and test every single part that we produce and see, hey, is this stronger than the last one? Because how do you test that? Well, you take your part and you bend it as until it breaks, and then you can say, okay, at this at this level, that part broke. Maybe it was 1,000 pounds, or maybe it was you know 700 pounds, whatever it is. The old part, which broke at a certain level, but like you can't test every single part you produce of these new parts because that would mean you're breaking all of them. You don't have any left to install, okay, in the planes. So you have to take a sample, and this is what they actually do for quality testing: is you take a sample and you test those. So let's say we test like 2,000 of these parts that we produce. After we test them, they're not going to be usable, okay? But it'll tell us if the entire population is stronger or not, okay? But we don't know that for sure because we're doing a random sample, okay? So there's a chance that we make an error because it's random. You'll never make a type 1 error or a type 2 error if you test the entire population, okay? But as I said, you can't do that, okay? So down here, our decision is not whether it's stronger or not. We're going to test a sample and see, okay, the sample is going to tell us if it's stronger or not. Okay. And then from there, we're going to make a decision what to do with the rest of the parts that we did not test, the rest of the population. So if we do not reject the null hypothesis, then that means that we assume that the new part is not stronger, which means we're just going to keep using the old parts, the parts that we've been using for years. We know these parts work, so we will not install. We'll not install the new part. That's not what we want to have happen. We're producing these new parts because we think they're better. Usually we want to reject the null hypothesis if we can, because that means we will install. Okay. All right. So we'll let you fill in. We'll come back and we'll fill in the rest in a second. Okay. All right. Let's go to page 528. All right. Verify the conditions to conduct a hypothesis test are met. So we need to make sure that this is random, independent, and okay. So we're hoping for 3 yeses. Test your claim at a 1% significance level, showing all steps, works, and graph. Use minutes, not hours. How many minutes are in 2 hours? This question for you guys. How many minutes are in 2 hours? All right, yes. So there's 6 steps. Step 1, step 2, step 3. And these steps are on page 262 and page 263. Now, for this case, we are measuring the length of a movie. So that is not a proportion. Okay. The average length of a movie is like 120 minutes. Okay. So we are going to be using page 263. Okay. All right. Um, so for question 7, um, verify the conditions, the requirements to conduct a hypothesis test are met. So random, independent, and normal. As the researchers claim at a 1% significance level. Okay, so keep using fractions for P0. So again, we have 6 steps here. This will be on page 262 because we're looking at probabilities. Now, step 1 was actually done for, we'll actually do up here. This is like step 1, where you write out the null hypothesis and the alternative hypothesis. So we don't necessarily have to write out step 1 again. Okay, so you got step 2 though, step 3, step 4, step 3 over here. Step 5, step 6. Okay. Okay. I think that's all the hints. Let's pause the recording.